All right, we're going to just take off. Let's see. If you're thinking about a workshop in the future, there, he made it. I did leave one off. We were going to be in Vegas in September, but all of that is available. So we'll get the ads away. And what I'm going to do to start with is just go through the basic settings and kind of give you an explanation of what each setting does. This is something that I spend a full 8 to 5 day on in class, so this will be a condensed version, but hopefully you'll find it helpful, and we'll cover some stuff that you may not know. So when you bring up the settings menu, depending on what levels of software you have, you're going to have some possibly that looks a little different. This is the advanced design. If you only have basic design, you're going to have a lot less options on this page. I'm going to go ahead and talk about all of the options. That way you can use the ones that apply to you. So in the design tab, let me give you a quick primer here. And if you have a question about what we're talking about as we go, just type it in and I'll watch that comment section and try to address it. And if you can't hear me okay, let me know. So real quick, just kind of a basic thing to keep in mind when you're doing settings is the first two tabs, the design and the offset convert tab, only apply to new things that you're going to create. Those two tabs don't make any changes to your existing drawing or to the way the machine operates. So the design tab has some view options that that do change, but most importantly, when we look over at that offset convert tab, if you make changes to your kerf setting, nothing happens to your drawing. If you need to make you'll need to delete a cut path and create a new one for those changes to have any effect. And then on the machine control and height control tabs, those are real-time changes. So when you make a change and then do a cut, it will make sure somebody's not having trouble. It will change the way that it cuts right then for the next cut. So looking first at the drawing view box, you've got the option to show closed paths and show wide cut paths. Those two settings are similar, and they're pieces that change the way the screen looks. If you only have basic design, you don't have the option to have that closed path shown. But where it comes in handy is if you've got closed paths filled, then you can see if you've got islands out in the middle that aren't going to cut or that you would need to bridge in. If you had that setting turned off, then all you've got is little lines. So it's a little harder to see. I operate with that on. And then for the show wide cut paths, when you convert this to a cut path, it will offset half the amount that you have set in your kerf setting. And so when you zoom in, you can see the shaded area. It's essentially showing you what the kerf that's going to be removed when the torch cuts that piece. It's kind of nice to be able to look at that, especially if you're using a setting we'll talk about later that is overcut to reduce undercut. You can make sure that your piece isn't going to burn up and fall apart. Show the table edge is kind of explanatory. It just draws the table on the screen. Probably a lot of you may still use show grate points, and all that does is show you where the grate points are on the factory PlasmaCam grate system. And that's nice if you needed to place something on your table and have it where it didn't tip. You could move it around so that you were sure that it sits on grate points, or not have a pierce directly over a grate point. But for me, two problems with that. First, in design, I find it easier to see a grid and I set that spacing to 1 inch so I can tell the size of something. And then the other problem for me is I've already replaced my grates with a completely different system, so those grate points don't even exist on my table. But you can, personally, I like to see it on a 1 inch spacing for design work, and you may choose to, if you have a dedicated table computer, to have it on the grate points all the time, or switch back and forth. With Show Grid, I believe it's advanced design to show that and have the third level, but I'm not sure. It may work in basic also. But if you look, that's kind of a grayed out check mark. And what that means is the grid area is only inside the table. But if you're designing something larger, or you want to work outside the grid, you can table, you can click that one more time and turn it black, and then you can get grid everywhere. And that's nice if you're doing something bigger. If you zoom out too far, just like on the table, the grid goes away. So, but you can come off out in space and work with a grid out here. And I just toggle that on when I need it. And of course, if you don't have Show Grid at all, then you have nothing. The grid point spacing that I use is 1 inch. That's the distance between the dots, and the snaps per grid point I use is 4, and that gives me a 1/4 inch increment snaps. Uh-oh, you lost me screen, voice, or both. Okay, we'll keep going. Hopefully we're recording okay. So the snap points for the grid, all that means is when you're using a grid snap, which is you can lock on in your settings, snap to the grid. And essentially, if I draw myself a circle, so there's a small circle. So you can see that as I drag that around, it doesn't move, and it's snapping at 1/4 inch increments because I have it set at a grid spacing of 4. And so if I wanted to go over a half and up a half, I know that's exactly the right spot. So you can use that, especially handy for dimensioned parts when you're drawing it using a grid snap. And like I said, I use 1/4 inch just because it's easy. You put too many snaps per grid, you can't tell what you're doing. If you had 16 of them going across there to do it in 16th, it'd be very hard to do. On the automatic backup, I change that down to 5 minutes and have it auto save. This doesn't save the file anywhere under a specific name, but if your computer locks up or you lose power or have a problem, hopefully when you turn it back on and load Design Edge back up, it will give you a notice and tell you that a drawing has been recovered. And that's all that does. So I have it try to update that every 5 minutes. And the undo redo depth that I have here is just whatever comes factory, and I've never had it be a problem. 10 and 50, that's just the depth that it will go backwards. And I mean, I've undone probably 60 or 70 steps before without much trouble. So if you find that you run out of undo and you need more, you could probably change the minimum up or give it some more memory. Node precision. For plasma cutting, 100 will work just fine. That is how many nodes are in a 1 inch circle. So if I draw a 1 inch circle and I look at that, you can see that it has 101 nodes. That's 100 nodes and then one where it connects. That is plenty resolution for plasma cutting. Sometimes I kick it up to do laser work when I design laser files because they're extremely small. But if you have that set too low, then you wind up with a jaggedy arc or curve or circle. So you want to have the high enough number in there that you have a nice smooth arc. that pretty much you leave alone. The biggest time I run into people with arc resolution setting problems is if they've accidentally set it too low and have that jagged stuff, or they've accidentally set it way too high. And when they try to smooth or detect intersections or join paths, it's 100, 200,000 nodes, and their computer bogs down trying to process all of that. So if you have problems, that's where you need to look for that. And then the gap distance to treat as an intersection, that's a default again. If you have advanced design, you have a dimensions toolbox, and all this is talking about is the actual dimension tool. So if you were to manually draw a dimension using Control D, then this would be the text height, and then the linear decimal places that it's carried to. And if you did dimension an angle, you know how many decimal places it will carry to for the angle measurement. If you open up your draw menu and the dimensions at the bottom and it's grayed out, it's probably because you've never clicked this button and gone in and set a font. You must go in and set a font, and this is where you can change what font it uses for the numbers in your dimension. Smooth paths, we use smoothing a lot. I typically smooth any drawing that I do just before I convert it to a cut path and wind up with much better results. Factory setting is 5, right in the middle. All that is, that smooth level is what your computer processor is able to do. So how precise do you want to be based on and then how long do you want it to take to calculate that? And you always want to find arcs during smoothing. That simplifies things and reduces the nodes required. Okay, default on link paths. I believe one of these is defaulted with something in it. Personally, I set them both to 0. So the link paths, the gap distance to jump, that is if you have a drawing that may be a series of lines that don't join up. Then when you select that and try to J-join it or J-link it, nothing's going to happen. But if you have something in this box, I'm going to put a big number to show, then it'll join it up and it'll jump those together. The problem is it moves it. So you see it moved and changed the dimensions of my piece. And so personally, I set those to 0 and fix the problem myself. But sometimes if you get one of those lovely, terrible files off of Plasma Spider that's all broken up, you can actually go in and set it to a small number, 0.01, 0.02, 0.005. I mean, you can play with it until you get it to join up and you can fix things. The same thing goes for this delete overlapping segments. When I'm designing, I may, through changes, drawings, doings, I may have something that comes down very small that I want to then fill it or work with laser. And the problem is, if you have, I'm going to connect this back here. So if I hit J to join that up or link it, see how it joins it together. Now I can fill it that back and fix it so that I can cut it. But if I were designing and I had this delete overlapping segments and I had a number in there and I tried to join my drawing up, it deleted the overlapping, what it thought was overlapping, and it didn't link it together. And so rather than fight that thing erasing itself backwards, just put a 0 in this box unless you need to fix a problem. All right, that was a quick run through on the design tab. Does anybody have any particular questions that I didn't cover well or that you had another question about? And then if not, we will move on to the offset convert tab. Scott, did you make it back? We can always circle back to questions later also. So on the offset convert tab, again, this, as I said in the beginning, this tab does not make changes to existing drawings or cut paths. So your kerf is the number that you put in there is the actual kerf, the actual amount of material that your plasma cutter is taking out when it cuts a path. And that's going to vary based on the consumables, the amperage, the material, the thickness of the material. So this is something that's dynamic. You have to change this depending on what you're doing. So the trick to that, though, is you have to measure the kerf in order to set it. In the Hypertherm manual, which is what I use, you'll find that it gives you a sheet of estimated kerf widths. But estimated is just an estimate. So the easiest way, I'll give you my tried and true secret method for setting the kerf. And that is to come here to this box, set it to 0, tell it OK. And then draw yourself a 2-inch square and then convert it to a cut path. And when you do that, it cuts directly on top of that 2-inch square. And so then you can measure that square. And what you'll find is, get rid of that. When you cut it, and it takes the kerf off, when you measure that with a caliper, you're going to have a number that's smaller than 2. So we drew it at 2, and we cut it, and it measures 1.96. So what that would tell me is my kerf is whatever 2 minus this number is. So my kerf would be 0.04. And then I can go back in and set my kerf to 0.04. And then once I do that, you can kind of see what happened over here, because we cut right on this line, but it took half the kerf when it went down this side, half of the kerf when it went down the other side. So that's why we can take our 2-inch drawing minus whatever the kerf is and get that setting. And then when we convert that again, what will happen when we do a new cut path is you can see it now, it's offset half the width of the kerf, and so it will actually cut a 2-inch piece out. So that's the quick and dirty way to set your kerf. Pierce lead in, that's something that you set based on how long you want that lead in to be. I'll get to that one, Chris. We'll talk about those levels because there's several upgrades. There's a basic to advanced in design, and then there's a basic to advanced in machine control. Right now, you're seeing the differences that show up in the design setting, the basic to advanced design. And there's a box right over here we're going to get to called exclude crossovers, and in my opinion, that box is worth $1,000. So the answer is yes for basic to advanced design, but I'll tell you a little more about why here in just a minute. So back to our Pierce lead in, that's for me, for thin material, 0.15 is where I put it. That's far enough away. If you're doing thicker material that's going to have a bigger pierce hole, then you're going to need to back that up so you can make that a larger number. So you can adjust that. And I do check the move lead in for best fit. The gap at the end of the loop. So a lot of people try to fix a problem, and what the problem that they are working on is when you cut, let's say, an inside hole on your artwork, and right directly across from where the lead in comes into the cut path, there's a little divot in your piece, and invariably they want to know how to change the angle for the lead in to come in, what is it about the lead in that's causing this problem. And 9 times out of 10, the actual problem is not happening at the beginning of the cut, but actually at the end, because when the torch comes back around and it cuts over the top of that material where it's already been cut, it does go out to try to get more material. And so that's actually where it causes the divot. You can fix that problem by adding yourself a little gap at the end of the loop for the torch to actually stop motion before it gets all the way back to the end. And as long as that number is at or less than about half of your kerf, the piece will still fall out. If you wanted it to leave a little tab to hold something in, you could actually put a number there and it would kind of make its own one little tab for you to hold it in. So, okay, before we jump into the overcut to reduce undercut, which is another one that a lot of people don't understand or don't get, we'll look at that. So it's going to work the same for holes. Ron, when we set our kerf right, we're doing the outside offset so that we can measure that piece that falls out. And really that continues on to Scott's comment too. So the reason that I cut this piece instead of trying to use a caliper and get the little ears to fit in my kerf in a flat sheet is for that very reason. I can use that caliper now and kind of get a good average or take into account all of the taper. You should only be getting about a 3-degree taper at worst. And it should be a positive taper in from all directions. But when you do cut that test piece, and I'm talking about on small metal. For bigger stuff, I don't do that. I don't cut a 2-inch square out of 3/4 inch plate to set the kerf because that's a big pain. That's not going to happen. But I do try to measure it, with a straight line cut. But for your to take the taper into account, that's why I cut that piece of square, and I can actually, get the caliper on it and get it set the way I want. And so then, Ron, once that is set, then your kerf is correct. And so, yes, it will offset to the inside the correct amount for a hole, just like it does to the outside to cut a piece that's going to fall out. The only big difference is, air plasma sucks at very small holes. It's just the fact of life. As that torch goes around trying to run the arc, the actual torch flame lags backwards, and you wind up with a more taper on a small round hole than you would on a straight line cut. So if you need to have a perfect hole, then what I do is mark it and drill it, or cut it and use a bridge reamer to open the hole up. So there's a few different ways to get a good small hole, but if you're doing 1/4 inch and under holes, then even if your kerf is set right, the hole is probably going to be too small. If you need a bolt to fit through it, I cut a test hole and see if my bolt will drop through, and adjust the actual size of the drawn hole until I get it to fall through. So, oh, good. Yeah, yes, I love geometry. So, overcut to reduce undercutting. That is one that I see a lot of pictures people post of these split monograms. So you got the big letter with the person's name in the middle of it, and they've drawn it, and then they have left this overcut to reduce undercutting on, and their letters look very bad. So let me just kind of draw what I'm talking about. It really is a very simple thing to turn off and on when you need it. Well, obviously I don't want that. Okay. So let's do this name like this. And let's say we're going to put it in here. Like that. So when you put this all together, you know, you're going to trim these pieces out. You're going to trim these pieces out. Like that. Like that. And so when you convert that to a cut path, the torch is going to try to get back into that spot as far as it can go. Okay, and it's going to go till it can't go anymore, and then it's going to come back out unless you have overcut to reduce undercutting turned on. So I'm going to turn it off first, and I'm going to show you this cut path. And you see what it does. It goes in, stops, comes back out. If I have overcut to reduce undercutting turned on, what that does is try to make the part look more like what I've drawn. So it'll actually go on in just a little bit and then come back out. And the problem with that is, see how it looks when you cut it. Now it has little scoops, little divots cut in above and below the O's and C's, and it just looks generally pretty bad. So turn this overcut to reduce undercutting off, and be sure that you know, sometimes you want it to hold detail. It looks good, it works well, but with text specifically and curves coming into a flat line, it looks worse. So the overcutting to reduce undercutting helps it go down in and come back out. Let's see, how am I training without using the cutting tool? You're talking about at the workshops when we do those. What I have found from the several classes we've done and the classes I've held for the state VOAG teachers is that cutting is fun to watch, but there's not much to learn there. We all have these machines at home, and so if you have the settings right and the file drawn right, then setting up the actual plasma cutter is a pretty much walk in the park. And I mean, I'll let people that have been to the class comment on that if they want to, but you know, we do try to go to a local shop if there's one available close by, and it's a fun field trip, but I don't feel like it's that earth-shattering in information. I've got pictures, what, you know, the actual to demonstrate how the plasma cutting works, and we talk a lot about the theory and good installation practices and what consumables to use. So once you have that information, then you know it's a pretty easy deal. So let's see. How am I gentle? Oh, I use the X. I use the trim tool. Yeah. It's sorry. I mean, since that's not what I'm doing today necessarily. I'm just kind of flying through that. But yeah, there's a lot of tools that I'm using along the way to manipulate size and get things put together that if I went on to explain, we'd be having a 3-day video. And so we're not going to do that, but I did use the X trim tool to put those together. There's Howard. Yeah, Jay to join them. Minimize double cutting. If you're doing overcut to reduce, you want that checked. So to delete the delete small holes below and the replace old cut paths, I don't typically use this replace old cut paths. I just delete them myself. But if you had this on, if there was an old cut path within a certain tolerance, you know, to the new one you wanted to create, it would delete the old one. So could be handy, just not something I use. Delete small holes. If you've got a drawing that's got, well, look, Howard's name right up there. If you've got a drawing and it's got some noise in it, and you want to convert that to a cut path, if you have the delete small holes not checked, it's going to convert every one of those to a cut path. But if you had a drawing that had more design in it that you could do, then you could have a number in there. And then when you converted it, it would ignore those smaller than your setting and convert the ones that were bigger. So if you've got something with too much noise in it, then you can use that delete small holes. It does. I mean, the wording is confusing. Yeah, and we're gonna look at those briefly here at the end on the importing pictures, because that's not something that I went over in my previous classes that I've added to the PowerPoint. So I owe these guys that have been to my classes a little bit on that. So stick with me, and we're going to look at that at the end and talk about the automatic tracing that's in Design Edge, because it really does work pretty well. I mean, I have other software that probably does it better, but it does work pretty well. So this delete small holes bit, that really, delete's not the right word. Ignore would be a better word here. So to ignore the small holes when converting to a cut path that are below a certain size is what that means. If you're trying to convert one and you have something there, it will give you a warning to tell you that it is unable to convert it. And that's because of that setting right there. If you have something in there, it'll tell you it can't do it. So let's see. So cut path direction, always you want that always with plasma cutting to be cut to the right, and all that does is cut clockwise on perimeter paths, counterclockwise on interior paths, and that is because plasma is a directional process. You can change the cut path order if you have advanced design, and to do that, then you can set what order you want it to cut it in. You can have it sweep across one side of the sheet to the other. You can have it minimize the rapid travel overall, or have it to try to jump around to reduce heat to help warping problems. Offset, and here's your $1,000 check mark. If you don't have advanced design, you don't have this check mark, and so you don't have any way to exclude those. And all that is on tight inside corners. Instead of having the little loop on the end, it will trim. It'll get rid of that, and that alone is worth the upgrade. Never mind being able to check the cut path order and to see solid shapes on the screen. I mean, there's so many other things. That one's a biggie. And I'm not going to go into bin line conversion today. That one is a good one for another time. But we're already 40 minutes in, and we've made through the first two tabs. So any other questions on the offset convert tab that I didn't cover you had a question about? No? All right. If you got one, save it for later. We'll come back to it. What you see now is machine control tab. Remember, the settings that you change here we'll come back to that. I'll hit that in a little bit, Scott. What we change here is an actual real-time change. So you're making a change on your table computer. Settings here have no bearing whatsoever on your design computer. They don't do anything except to change if you were to use the measure tool to show you how long it's going to take to cut a piece. Then that's the only thing it would change. It wouldn't change anything about, the actual part that you save when you go to your table computer. If you have a design seat, when you take this file, none of this comes over. So this is what you're going to set based on your material that you're using. Rapid travel, pick your poison. That's your own baby. It doesn't matter. I leave mine on 1,000. I've got a 5-foot by 10-foot table, and I just wanted to get there. So I leave that high. If I didn't have advanced machine, or if I didn't have advanced height control, and I was worried about catching tip ups, or if I had a smaller table, I might run that number, down considerably, just to keep it from being rough, or so I could catch it before a tip up. So you can set that there. If you have advanced machine control, if you have basic, all you've got is the speed. If you have advanced, then you have this pause before rapid travel, and you'll also have this pause before cutting. So I'm going to talk about those. If you put check marks in those, it will wait for your input every time before it does whichever you pick. So if you have before rapid travel checked, you have to tell it okay before it can rapid travel after every cut. So if it's asking you that and you don't know why, this is where you go to fix that. Move home after cutting, that takes the machine to its mechanical home, which on the 5x10 is 00. On the 4x4, it's 048. It's actually a different spot than the corner of the drawing, and I'm still not sure where it is on a Go Torch, but I think it's 024, but don't make me lie. So cutting motion, this cut speed number, this is going to come, and I'm going to talk about Hypertherm mostly when I talk about plasma cutting, because it's what I use, it's what I recommend, and it's all I ever use. So other than helping other owners who have different machines, either to help them get theirs working or to help them want to buy a Hypertherm, that's all I've done. So when I say get it from the book, I mean get it from the book in Hypertherm. If you have a different brand machine, that may not be the case, because Miller is they're crazy. Their numbers don't work. You've got to start with what they say in their book, and then adjust from there. Gail, the acceleration and the other options are part of the advanced machine control. So that's another $9.98. And it's a great upgrade if you do a lot of small cutting, but that's why you're not seeing those, because it's an advanced machine control upgrade. Now, when we get to the next page on height control, ours will look just the same. So your cut speed, you're going to get four things, and I'm going to circle back around to this, and my class is tired of hearing them, but you're going to set four things before you start to cut. And those four things are the pierce height and cut height, which are on our height control page. Two of them are on this page. That is your cut speed and your time to pierce the path. So those two things are going to come from, if you have a Hypertherm, that cut chart in your book based on the amperage, the material that you're going to use, and the consumables, whether you're using regular shielded or a fine cut or just what you're doing. So I'm going to give you the quick rundown on what I do for acceleration. It's a starting point. You can fine tune this for your application. If my cut speed is 150 inches a minute or more, I set the corner acceleration to 0.05 and do slower on circles and curves at 2. And these are advanced machine control options. If you have basic, you don't have that. You'll have to set just the cut speed. The acceleration is fixed by the machine. And so we don't have any way to change that. But if you're getting weighty cuts on small stuff, if you're trying to cut in 16, 18 gauge, maybe even 14 gauge, and your cut speed is up, above 150, then I slow that acceleration down by changing it from, I think, 0.2 to 0.05. And then the slower on circles and curves under 2, that just lets it slow down more often. And so that will help get quality cuts on that small stuff. So now if your cut speed is less than 150, so now if I'm going to say 80 to 150 or so, then I'm going to change that corner acceleration to 0.1, and I'm going to go slower on circles and curves under 1. Because your cut speed starts out slower, you don't need to reduce it as dramatically as you do the faster cut speed to get good quality. So Those are my recommendations, and those are some place to start. And then you play with it and get it to work just exactly the way you want it to, for the material and your air conditions at your shop, the climate, all of that affects that. Z motion, that Z-axis speed of 104.5, that's, I believe, the max, and all that really is the jog speed, unless you go slow it down below 50 something, which is, you know, your settings in the height control. But as long as you're up above 50 or so, you're not affecting your height control speeds. The force when moving, you can adjust that if you only had basic height and you wanted it to go with less force, on the stall to 0. If you're doing some painted material or something, you could back that off. What most of the time I have to address that setting with folks is when they've accidentally set it to 0 and the Z-axis won't hold itself up, and it just droops, and so they've accidentally put that to 0. So if the Z-axis just falls down and won't even hold the torch up, then probably better have a peek and see if you didn't mess that setting up. Okay, the time delays. So time to mark a point, if you draw just a point, and or say you're doing it to let me just show you that real quick. If you're doing it to say I need to drill a hole, then you use Control Q or draw point right there, and you can draw this point, and then when you convert it to a cut path, it just makes it a pierce, and it'll do that. If I did the perimeter as a hole, it'll call it a hole and convert it. So that little single dot 0 length point is what it's talking about in this setting here. And so that's the length of the time the torch fires to mark that point. And 0.1 seconds works pretty well for most material. 14 gauge is going to blow through it. But anything thicker than that is just going to make a divot so that you can drill a hole. Let's see. Okay, got that. So the time to pierce the path, that is a pierce delay from your Hypertherm book or your plasma cutter manual. Thermodynamics, by the way, they're pretty good on their settings. I think you're okay with most of those. So Hypertherm does not recommend a moving or a wiggle pierce. The time to continue cutting at the end of the path, the only time I really use that is when I'm cutting thick material, be it 1/2 or 3/4, with my little 65 amp machine. And that's just so the torch drag can catch up when it gets to the end. And all that number does, if it's positive, is at the end of the path, the torch stops moving and it will continue to fire for the length of time you have set there. The only problem with doing that is it will also cause that divot that we talked about earlier. And so you have to have a good balance. So you'll have to play with that number if you have a problem with the thicker piece not falling out. Also, you can add time here in a negative number, and it'll actually stop firing and keep moving at the end of the path. And that's good if you want to add a little tab, but not much else. So, and then wait for cutting signal before moving. That's going to come if you have height control. And so all that does, and that's based on your manual or which cutter you have, doesn't come from your manual at all, but 3 and 12 work most of the time. So unless you're fixing a problem, you're not going to change those, and you're going to want that wait for signal before moving so that it does make sure that the torch fires before it starts the pierce time countdown, and then takes off in the cutting path. And if it loses signal along the way, it will stop if you forgot to turn on the air compressor. We're not going to do indexing, and don't check this center moving torch on the screen unless you have a few vodka drinks first, because it will drive you crazy. Let's see. I'm not sure on that. Let's look. Oops, I didn't have that set up on here. away. There. Okay. Well, it hates me. So, let's look. I didn't set it. So if I turn machine control back to basic, yep, sure is. That's what we're looking at now is the basic, the machine control page. If you have basic machine control and do not have advanced, so you don't have those extra settings, you'll just be able to set the time to pierce or the pierce delay. Let's see. I got a new computer for Christmas and I do not have that little piece set up. I usually have a hotkey assigned for that one. There. Now it's up. Okay. So let me turn that back on. Go back to those settings. Yeah. Yeah, that's for sure. That is an advanced piece. And I can tell you, I mean, I ran my table for probably 4 years before I got the advanced machine design, upgrade, and I wish I'd gotten it a whole lot sooner, you know, based on that. Let's see. Okay, so there's machine control. We've kind of hit the high points of that. Oh, that's all right. I got new fiber internet, so I'm very excited. It works very fast. Before I was the one causing all the lag. So that's a good run through on machine control. Like I said, the high point of this is if you have advanced machine control, set that acceleration based on your cut speed. But most importantly, the two things that you're going to set from your manual or your cut charts is the cut speed and the time to pierce the path or the pierce delay. And with that, we will move on to height control after I come back here. Scott, you asked what about same as source. Cut path direction, you would never want same as source because that is essentially the direction that it was drawn, and you would want it to cut the same way. So that's not helpful for plasma cutting. As far as cut path order, same as source just means the order that they're drawn in. So if I draw, let's say I draw the letter R, if I draw the outside first and then the hole in the middle, then if I cut path order is the same as source, it will cut the outside first and then try to cut the hole out of the middle after it fell out. So again, not a very handy thing unless you specifically draw it with the cut path order in mind. Typically, I'm setting it as either minimize rapid travel or reduce heat. So, all right, let's run through some height control stuff. And what you're going to see on my screen is the advanced height control. Basic height control is very, very much like this. The only difference between basic and advanced, well, there's two, but the main one is ohmic sensing. So you will not have the sense to material to zero option. You will only have stall or from previous. But with ohmic, you'll have over travel for sense and a sense material to zero. The other thing is you won't have the ability to change the advanced settings, but that's a whole nother session. So in basic height control box for height control, you're going to set your material thickness. All this is for figuring the volume when you measure it and for knowing how much room you've taken out of the z-axis travel because of the thickness of the material. You can set this on 0 and cut to your little heart's content. It doesn't care. That's all it tells you. It has nothing to do with the actual thickness of the material or any of the controls. So raise and lower between cuts. That's definitely, you do want it to do that. And so here you can set your rapid travel height, and that's just a height that it fits within the room you have left. at the top above the plate, and it has to be higher or equal to the pierce height. And all that is to clear tip ups or to clear the top of the material. The farther you go, the safer it may be, but the longer you have to wait for it to come down at every cut. Pierce height comes from the cut chart. Always, always. Most Hypertherm pierce heights are 0.15. If you uncheck this use torch height control, it still sets your pierce height, and your cut height setting still matters. But all that does is turn off the automatic adjustment while it's cutting, the voltage feedback. So it will be a manually set cut height, completely, regardless of any warpage or unlevel cutting surface or whatever. So you can turn that off if you have something like 3/4 inch plate that you know your table's perfectly level and you don't want to use the torch height control. You can turn that off, but the pierce height and cut height and how it gets that reference still apply. So if you have that checked, then it does use the voltage feedback and adjust the cut height. Pierce height reference, if you do from previous, then all that does is run over and go down to the pierce height that it assumes to be correct based on the Z shift that you have set, which is what tells it where the top of the plate is. So if you manually set your Z shift by running it down to the surface of the metal, opening this box and clicking the 0 button, then if it's a 1/2 inch higher at a different spot on the table, this is going to be a problem because it's not going to sense that pierce height. It's going to assume that you were correct in telling it where it was. Has a lot of use. I use it a lot when I'm routing because wood doesn't warp, and I've already fly cut a spoil board, so I know everything's flat and true. But for plasma cutting, you're almost always going to want to use if you have advanced sense to 0. But let's talk about stall to 0. That's where your torch goes down, and since the Z-axis is a stepper motor, it pushes down on the surface of the metal and stalls out to 0 so that it knows where the surface of the metal is. You don't want a terribly large number in here because the bigger the number, the longer it stalls out and the better chance it can deflect. But if you put too small of a number, then it won't reach the metal, and if it's low in a spot, and you'll have problems for that. So stall still works. If it's very thin metal, though, it will deflect, and so you may have to use from previous location and just watch it very carefully and save up for that $9.98 to get from basic height control to advanced, where you can use the sense material to 0. And when you do that, the over travel can be a big number. Doesn't matter, because as soon as the shield of the torch touches the surface of the metal, it stops, and it has sensed the material. It knows exactly where it is, raises up to the pierce height and pierces, then drops to the cut height and takes off cutting. So then you have the material sensing errors for the report if material's not sensed, report if there's contact on rapid travel, so if it hits something while it's moving. And you can also sometimes use this retract Z if it detects a contact while it's cutting. I typically use that as off unless I'm have a problem with the torch diving. So you're going to want to, if you have this box, to disable the height control when it's crossing the kerf, and you're going to want to disable when the cut speed slows down below about 90%. And that has to do with your acceleration setting. I don't know if this is available with basic machine control or if it's part of advanced or height or what, but essentially if the cut speed slows down, you need to disable the height control, otherwise the torch is going to dive. And so make sure that's checked and start with about 90%. And so to wrap up the height control bit, I'm going to give you the spiel again of those 4 important things, and that is to set the pierce height, the cut height, the cut speed, and the pierce delay or time to pierce the path. Set those 4 things and then do these next steps, and you'll be much happier with the way you get it cut. And this is with advanced height I'm going to talk about. If you have basic height, then you may have to zero the Z-shift yourself. But in advanced with ohmic sensing, we can auto zero it. So if this were hooked to the table, these little boxes would be lit up. So I've set my 4 important things, and then I go in here and I check the auto zero Z shift, and I put a check in this auto zero arc voltage shift box, and I tell it okay. And then I draw on my table in a scrap piece of area of the material a straight line that's at least 6 inches long, convert it to a cut path, and then cut it. And when you do that, then when you open up that setting box again, you'll see that the arc voltage shift has changed and the Z shift has changed if you have advanced or use stall, and the boxes will have cleared themselves. And what that does is it adjusts the height control arc voltage scale, the shift, so that it'll cut at the right height based on the material that you're cutting, the chemistry in that plate, how worn your consumables are, what kind of consumables you're using. This is what takes the place of having to manually set a voltage from your Hypertherm or whatever brand cut chart. So much easier, much more user-friendly to be able to check those auto zero boxes. So do those things, set the 4 things, draw your 6-inch test line, convert it to a cut path, check both of these boxes and cut that line first. Do that at the start of the day, middle of the day, whenever you are getting bad cuts, and that will re-zero and reset your cut height so that your cut height is correct. So before we look at the import settings for pictures real quick, is there anything on height control or that we've talked about already that you have a question about? Always have to grow. So you're having to chill out. Well, that's not normal. You're using a Hypertherm? And are your speeds directly out of the book? That would be my other question. A lot of times people try to outthink those Hypertherm engineers and slow the cut speed way down. So sometimes I do have to slow it down a little, but not crazy. And so if your cut speed is way, way, way off from the book, then maybe you've got a problem there. But you shouldn't have to. I mean, I never, ever, never manually adjust my my arc voltage shift. Let's see. I don't know. I got all kinds of stuff here. Trying to find a decent picture. Here's one right here. Let's open this one. I drew this one for a person, and I know it's not perfect. So let's look briefly at the different ways, maybe that is the one I drew, that you can import and auto vector an image and what these settings do. So this is a black and white picture, so I'm going to leave it black and white. I'll pull up color when I show you that in a second. The very next screen, after you have told it that you want to convert the image to vectors automatically, and you'll want to set the size. But the next thing is to pick your background color or colors. As you can see, it's going to be more important when we're doing something with colors later. Then it shows you what you have your cursor over. So see, when I get over the black, it frames the black, and I can click that white background, and it will click it to remove it. So that'll get rid of it. And then the next screen shows you it in that color. Since it was already black and white, no difference. But this is a solid drawing, not a line drawing. So it is solid. We're going to leave it solid. And then we've got some basic settings for it. This is what it uses when it imports. So the maximum speckle width is in pixels. And all that is to reduce any noise that's in the drawing. So what that means is at 10 pixels, a width of 10 pixels, anything less than that will be ignored. So it will be considered a speckle that needs to not be converted if it's 10 pixels wide. So if you're getting a lot of noise in your conversion, you can up this slightly. Maximum edge fuzz width and minimum edge fuzz length are a little harder to explain, but I'll maybe draw a picture here and kind of show you. They work together with each other. So on the edges of this drawing that I'm going to import, if there was an imperfection or a little hair or something sticking out or a crack going into it, as long as it was longer in pixels than this length and narrower than 2 pixels at the width at the base of it, it would ignore it. And so it's hard. It's easier to show than explain. So I'm gonna grab that one on the screen here in a second. But then on edge rounding, all that is, these are smoothing functions. So the moving average filter, if you wanted it more rounded, that is the number of nodes that it takes into account when it rounds. So it smooths in 3 node increments, in 3 node sections to make curves. If I wanted it more rounded off, then I could increase the number of nodes to 4, 5, 6, 8, 10, and it would then sample a large area of nodes, however I set it, and would round those off and average their locations. So that one's not specifically like the smooth command, but it's something that is done that can smooth rough edges of a drawing or a file when you pull it in. The next option, that line smoothing in pixels, that is the exact same as using the smooth tool later. The margin is not the same. The numbers aren't the same because this is in pixels and the other one is in a margin or a ratio. But this particular deal, you can put that line smoothing to 0, smooth it later yourself, and have no difference. So let's go ahead and pull this in. And so you see what it did. It pulled in my drawing, and you can see if I turn that F11 to turn that off, that it vectorized the thing just fine. So I could do what I wanted with that, bridge it, cut it, fix it, whatever. To kind of give you an idea, so if on my smooth, or see, what was that setting called? I'm too old for this. Hope that's a good picture. Oh, okay, there you go. Called maximum. So I've got a maximum edge fuzz width and a minimum edge fuzz length. So the width is here, and this is in pixels that I'm talking about. So from here to here is the width. So if the width is less than the setting and this length, which is here, is more than that setting, then it will ignore that. And so you can adjust that to reduce the fuzz on the edge of your drawings. But remember, it's in pixels. So if you have a drawing that is very low resolution, you're going to have to use very low numbers. It's going to be relative to how many pixels per inch you've got in your drawing. So if this width were wider, then it would just smooth this off and there would be a bump if it were wider than that maximum width setting. But if it's narrower than this setting and longer than this setting, then it'll trim it off. So hopefully that makes a little more sense seeing it that way. So let's pull in another picture real quick. If we can find a color one. These are I can't see. So let's I know where we got one. So if you have a color picture that you need to do, then you can pull that in and delete certain parts of it. So if I wanted to do a layered sign with this, I could actually just keep one part of it this time and then import it again and then import it again until I got all of the pieces that I wanted. But what happens is with a color, you have to pick and it will convert it to one of these things. If I did 256 colors, for instance, I would have a whole pile of colors to sort through. And I can't figure out when you'd ever use that. Those 256 make no sense to me. You could get it probably in grayscale, but you see what happens with that, or you can probably get this one in color. And let's make that 30 inches wide for fun. And so when you tell it to import that and vector it, it will convert it to these colors. And then you can pick the background colors. And you can do it by clicking out here on the drawing or over here on the piece. So black is a background. And I'm going to say white is a background, so that's a gray color. I'm going to get rid of that. And I'm going to not do the reds. I don't think there are probably any. So what you can do at this point, once you've told it what you want to be, background, you can click next and see what it's going to look like. And you say, that's terrible, I don't like that. You can go in and pick different things, and control will add them or take them off. If it's easier, you can push select all and it will select all of them. And then you can go in and pick one color and tell it to hold control to unselect it. And so you can see that would be what I would get if I did just the red. And so you could go in, you could get that in a vector. And I could go in and fix it. But I can tell you that this one I manually traced because the picture is not good enough to have done that. But on purpose, I brought this in just to show you how that works. If you did something that was a little more clear, it would work a lot better. So I can go to 16 color, and all I have to do is I'll select all and I'll hold control and then next, and then you see what I wind up with. That way I can take that. That's something I can clean up. So hopefully that makes sense. I do use other programs to auto trace a lot because the settings for importing these in Design Edge is a little clunkier than some other interfaces I have. They're kind of more automatic, but I could certainly clean this up and get something working. And that's why I send my proofs, by the way, on those backgrounds, because then you have to work to clean it up. A little harder to steal my picture. Let's see. You can in Basic, yes. In Basic Design, you can do some of that. And I'll show you the difference. If you have Basic Design and I import that same picture, then this is what I get. You get 256 colors, like it or not. And so for you, I would say select all, hold Control, click on that red, maybe click on the yellow too, and then see where you're at. So this is basic design. So you can do some of it. And for black and white, it's a lot easier. If I have a black and white picture anywhere. Again, I'd hold Control. But even still, I mean, the problem with 256 colors is there's a lot of colors in there. So I might have to come over here and, you know, get several. Everything that's turned on is what's undone. So you'd have to go through and find them. It's a whole lot harder to do in basic than it is advanced. What I would probably recommend doing is actually going and making your picture a true black and white in another program, and I use one called paint.net. So I would open that file, and then I would convert it to black and white in this program. Let's see. Probably even you can paint it like this and make it all black. And then when you import it, you won't have all that crap to sort through. So I'll save it. So then importing it in basic, it should go a little easier. Because now I can select all, hold Control, and just pull that black out. Then I get that, and I get that. And then, of course, in basic design, remember, I cannot see that closed path. So that's all I'm going to get the purple lines. So, and then you can, I can turn that that advanced design back on, set my, to show it, and you can see what a good job it did tracing. Not bad. Some place to start from, and I can put my text back in manually. So that is about the end of what I have prepared. So I'm happy to answer any questions that you might have. I personally do because it's what I know. Inkscape to me is like speaking a foreign language. I tried to learn it, but it was more fight for me than it was worth. There are a lot of people that very successfully use Inkscape, and it will vector things and has text tools. So if you have basic design and you want to use some text tools that you are missing, then absolutely, Inkscape is a good option. But I personally, it and I don't seem to work the same. So I don't personally use it. Paint.net is not a raster or is not a vector program like Inkscape. So it's got erasers, and I mean, it's a raster image editing program only. So it's much more like Photoshop than it is Inkscape. But it's like Inkscape, it's free. And so has some very powerful tools that you can use, not the least of which would be when you're manually tracing. If you have advanced design and you're actually tracing a picture, let's see if I can find one. Again, new computer, nothing's where it used to be. Let's see, here we go. So if I'm tracing an actual picture, here's my child, we should use her. So if I wanted to trace this picture and make it into a sign, I could first come in and, get rid of the background that was bothering me, and clean that up. And then I could actually go into effects and artistic and maybe make an ink sketch and turn off colors. Since we're working with black and white and plasma, turn up my outline, and that would give me a more black and white rendition of how I could make it look in metal. So I just use those filters, and I would then import that picture, into Design Edge and draw all the features in. So yeah, well, Paint.net should work well for manipulating raster images like this one and others. I mean, I can trace that. I can see kind of what direction I would go with this. I would do the shirt, as solid. I would cut the little designs on the shirt out. I would outline the arm and have the crease in there and in here. So I mean, using the filters to set that up, I may do this 3 different ways and keep bringing it into Design Edge and do a different feature or a different drawing each time. But that would let me see how to trace that better than trying to come up with it on my own. Whoops, there, like that. So just a little easier for me to see. And like I said, I'll save that image 3 to 4 different ways and then make a sign out of it. So let's see. Oh, you're trying to sell upgrades, huh? I can tell you that the 4 upgrades that are well worth having are the 2 involved in height control, basic and advanced, and then advanced machine control, advanced height control, or advanced design. Advanced design, advanced height control, and advanced machine control, well worth it. If you want the nesting after that, marvelous. But those are the ones that I use. So, how do I trace in Design Edge? One little line at a time. My class will tell you it's Z-E, Z-E, Z-E. So I use the bulge tool a lot, which is the hotkey Z. So if I were importing this picture and I would set it to 30 inches wide, oops, I don't want to do that. So with advanced, I would show it in the drawing, but I would not have it converted to vectors. And that would pull this picture in. And then I could start tracing. If it's a straight line, I can just use L for line and go across. But if it's a curve, then I would use Z, and you can anchor each point of that curve. And then I'm using an endpoint snap to hook at each spot, and so you would just work your way around and go as far as you can until the radius changes. So there are other tools that do work. I think the curve tool is a possibility, and you can use anything. If like the stars down at the bottom, I didn't draw those stars when I did this file. And I mean, you just get faster and faster using the whatever tool you get comfortable with. I kind of rushed that a little bit so I can join it and show you. So it's just manually traced. And all I did was Z and then E for an endpoint snap every time I continued on, so that it would anchor the first point of my bulge to my previously drawn line. And then, like I said, for down here, I would just put Control Z. I would pick the shape of a star. I would, pick a diameter so that it was on the page, and then I would just scale it to fit. No way I would draw that manually. So, well, interesting you ask, because this laptop that I just got for my for Christmas is a Surface Book. It is the fastest and fanciest and largest capacity, and it has a Surface Pen. So yes, it works. I'm not used to it enough to get extremely good at it yet, but I'll show you what happens when I use it. So a T for trace, And then on the Surface Pen, when I hover it over, it moves the cursor around, and then when I click the button, it places it. And normally I wouldn't be doing this with the thing up there. So as you can see, it works. Then I can connect it and trim it and join it. And like about any time that you do a trace or a manual draw, you pretty much want to smooth that. That's H.005 enter, and then that smooths it up. So yes, it worked. Yes, I'm going to like it a lot more as I get more used to it, but it's very nice. Works great with the trace, and then I can also use it with the brush tool, you know, and come in with the pen. Kind of curve some things in, so just a little harder to see and do, but I like it a lot so far. Yeah, I have two. They're Samson 5x10 tables, but they're the same. So the Surface Book works on design. The Surface Book will not run the table. You'll need a desktop to run the table because you need a high voltage parallel card or parallel port. I would recommend the Axon version. Made in Canada, I think, but it's a very well made card for these tables, reduces communication errors, but most laptops, including the Surface Book, won't run the table. They won't do anything. There's just nowhere to plug the table in, and the USB to parallel adapter will not work. Well, there's John. I was just wrapping it up. All of them. This video, by the way, of course, will be available on the page after we're all done and save it. So it'll be here to watch later, and you can have it to refer back to on those settings if we covered them too fast. But has anybody else got any other questions before we wrap it up? If you're thinking about coming to a workshop, then it would, I think, be a great help, especially if you're learning the program. I've considered doing some online, you know, specifically online stuff, but it is it's just difficult to explain and demonstrate and show things you know, here like this. So I would encourage you that, you know, if you're considering doing an in-person one, that we cover a lot of this material a lot more in depth. So if you want to come, great, but I'm happy to get as much info out there as I can on these kind of videos. So, oh, let's see, we're asked a question about locating the last cut. If you, Gail, they're $465 a person, and that is we have those at hotel conference room. Try to have them in several locations across the country, and that includes the workshop, the materials, and lunch every day. So I try to have it places that are inexpensive to fly into. And let's see. Oh, I can do that. Sure. Yeah. So on Conrad's question, he's got the problem of you're cutting on the table. And let's see, let me open one here. So you're cutting on the table. You got your cut path out there, and you're cutting away. And especially if you have it set to reduce heat, it's jumping all around. But if you accidentally bump the button while it's in the middle of cutting, and it's cut all of these paths, but you've bumped it, you've had a tip up, it stopped for some reason. I'm going to select it like this, and you have to not pay attention to what I'm doing for this to work. But let's see, I'll get this right in a second. That's what it'll look like. So if it stopped cutting in the middle of your cut and it still has all of the paths highlighted that have not yet cut, but if you bump it, if you click on the table, your selection goes all the way. And so now you know that this is the last path that it did cut or that you still need to cut. Then what you're going to want to do, I simplified this and have only cut paths. It doesn't really matter if you have both. But what you're going to do is go select the one that still yet needs to cut, or the one that maybe is already the last one that cut, and then hit the number to the left of the number 1 key. That's your select window. And you're going to have them all sorted, but you need them in order of the path order. That's the order that they're going to cut in. Okay, so you're going to change it if you have it on length or node, set it to path order. And then all you have to do is click that one and drag it down and close this window, and that will select everything that has not yet cut, if that's where your last one was. If you picked this one and it did cut it successfully, but it just needs to move to the next one, just hold the control button down and unselect that one, and then tell it to take off, and it'll finish. So I think that's what you're after. Let's see, what was the other one? Let me see here. Saving configurations. So if you have advanced machine control, you have this option. And all you have to do to save a configuration or a setting is to make your changes and then click New. And so then you could call this, whatever it actually is, and then save. And so anytime you click New and Save, it adds to it. And then to load that, let's see, I guess you have to click something else. Okay. So then to load that, you would just pick which one out of the list you wanted to load. And if there is anything different in your settings that is different in the configuration, it will show you those here to the right side. And you can just click on it and click load, and it'll pull all those in. So you can make as many as you want new, and then if you need to delete one, that's the remove button. You can just click remove and it'll delete that one. So you can just add them as you go. You can start with the basics and then make some changes, and then load the basic one again and make your changes until you get all your settings the way you want them. So very good. Can you save the font? Let me see. With advanced. Oh, do you mean to okay. Do you mean so when you write a font in Design Edge, when you put text in it, then you've picked a font and you tell it okay and you draw it in. So that is no longer editable text. That becomes paths. So if I wanted to remember what font that was, I would need to put that somewhere else, and I just save that off out of the way. But that way I could duplicate it or add to it or change it later. But unfortunately, there's no way. Advanced Design is not, or Design Edge does not let you dynamically edit text. So hopefully that gives you some direction on that. If that didn't answer your question, let me know, and I will certainly try to get the correct question answered. But Advanced design does let you do things like fit it to a path. That basic doesn't. So I could fit that to this path and it would curve that text. Around the circle, so, or into a closed path, but see. So you could adjust it. So advanced design does allow you to do that, where basic does not. But still, yeah, if you want to remember what text you used, type the name of the font. And if you made any changes to it in the advanced window for making it bold, expanded, stenciled, rotated, or any changes you did, make notes of those so that you can duplicate it again in the future. So hopefully that gets that. All right. If that's it, I will bid you adieu. And if you have another question, get it in here. I'm happy to answer it. I will probably have another one of these after, probably after the Nashville class, which is the first week in February. And because then we'll be having another workshop in Tulsa. Should be the first. Let me see if it's the first week in April. I'm waiting to hear back from the hotel on that. It should be the 4th, 5th, and 6th of April in Tulsa, Oklahoma, and that one will be posted later. And then, of course, we'll be in Vegas in September. But Tulsa would be the next one coming up after Nashville. So, oh, yeah. Well, you know, but you can come here and see me here or on our little super secret private only for class attendees group. So we've got that too. But yeah, if you're thinking about coming, please get in touch. I'd be happy to help you and answer any questions about the workshop itself. But at this point, I'm going to call it a day, and my 5-year-old will be home pretty soon. So thank you everybody for coming, and we'll see you at the next video or at the next workshop.